All right, so today we're going to look at how concentrated solutions are. A concentration is the measure of the amount of solute that has been dissolved in a given amount of solvent. A concentrated solution has a lot of solvent, a dilute solution not so much. Here is kind of a spectrum for you. Dilute, not so much. And then concentrated, much more. I feel like that's common sense. Button will work. So we can do some fun math to figure out concentration is an actual number. It's not just a visual. So when you have a solute in solution is a solid, you can figure out your concentration by the mass of the solute over the mass of the solution. If both the solute and the solvents are liquids, you can do the volume of the solute over the volume of the solution. The key here is it's always the solute over the solution. If you're given the masses, do mass. If you're given the volumes, do the volumes. Molarity, this is a new concept for you. It's abbreviated with a capital M. It is important that you note it is capital because in a couple slides we will find something with a lowercase m. Molarity is the number of moles of solute dissolved in 1 liter of solution. So there's your formula, moles of solute over liters of solution, and the unit. You can either write the unit as moles over liters, or you can just write it as a capital M. However, if you can do stoichiometry problems, and so sometimes it's good to remember that it's moles over liters, especially when it comes to your CLEP test. You might have to do a problem and you'll be going, oh my gosh, I don't have enough information. And then if you just remember this, you're like, oh, but then I can get this unit to cancel out and I'm left with moles or something like that. It's one of those tools and tricks that we forget about. But anyway, so to do a problem, it says a solution is prepared by dissolving 42.23 grams of ammonium chloride into enough water to make a 500 milliliter solution. Calculate its molarity. So we need the moles over the solute divided by the liters of the solution. So the solution is 500 milliliters, so we need to convert that to liters. So that would be 0.5 liters, correct? So then we need to convert the 42.23 grams of ammonia chloride into moles. So 1 mole. And how do we figure out the grams? All of the masses. So 1 nitrogen plus 4 hydrogens plus 1 chlorine gives you about 53.5 grams. When you run the math here, it's 0.7893 moles of NH4Cl. So then you can just plug it into the formula up here. 0.7893 moles over 0.5 liters. And you get 1.579 moles, or molarity. I told you. Nice, simple arithmetic. Here is another problem dealing with molarity. Why don't you give this one a whirl? Hint, work backwards. All right, so what do we get here? Anybody? Final answer. 118.52 grams. Yes? No? Maybe so? No. Zoe, no.
I just left the 4.
All right, so you are given that your molarity is 0.250. You don't know how many moles of solute you have, and you know you have 3 liters. So you need to solve for your moles of solute, and you should get this to be 0.75 moles. Okay? Then all you got to do is convert that moles into grams. So 1 mole. And then you do the potassium permanganate, 1 potassium plus 1 manganese plus 4 oxygens, and that is 158.04-ish. And when you multiply that out, you should get the 118.53 grams. Do you see the error of your ways, ladies? Zoe? Lovely. All right, so when you make a solution, so a lot of times when you get a chemical, it's going to be in a powder form. So to make it into a solution, you add the correct mass of the solute to a volumetric flask, which is shown in the picture there. That has been filled halfway with distilled water. You can't use tap water because there's usually extra crap in tap water that will make your solution not be a pure solution. Swirl the solution until all of the solute dissolves. Then you add more distilled water until the water level reaches the line in the neck of the flask. So see, you might have to look on your iPads, but there's lines at various levels depending on how much solution you need to make. Cap the flask and invert it several times to completely mix the solution. Just fun facts there. Dilutions is adding additional water to a solution. It causes the concentration to decrease. Handy dandy formula there. M in this case is referring to molarity, not mass. V for volume. So we can run this equation if you want. When ordered from a chemical supply company, you have a molarity of 16 moles. How much of the stock solution of nitric acid needs to be used to make 8 liters at a 0.5 molar solution? So our initial molarity is 16. We don't know what the volume is. Our second molarity we need is 0.5, and our second volume is 8. And so you multiply it out and divide by 16. Fun little algebra there. And you should get your initial volume. You need to mix in 0.25 liters of water. That makes sense how to use that formula? These are nice, fun, easy formulas. Then the last way to measure concentration is with molality. This is with the little m. This is the moles of solute divided by the kilograms of the solvent. Used when studying properties related to vapor pressure and temperature. So determine the molality of a solution prepared by dissolving 28.6 grams of glucose in 250 grams of water. So the first step is to convert that 28.6 grams into moles. And that would be 180.18. 0.1587 moles. And then go ahead and use the molality formula equals the moles of solute, 0.1587 moles, over the kilograms of the solvent. Here it's 250 grams, so we convert that to kilograms by moving the decimal 3 places. And you will get 0.6348 molality.